A rectangular block with mass m kilograms is on a rough slope which has an angle of elevation of 30 degrees. The block is being held in place by a light extensible rope which makes an angle of 25 degrees to the slope. Draw force diagrams if the block is on the point of A moving up the slope, on B moving down the slope. So just at the point. Okay, so the block is at the point of moving up the slope. Now we've got a couple of words here. Light means that string has negligible mass. We can ignore the mass. And inextensible means that this rope will not change length. Okay, so the force diagram. So we have, first of all, the weight acting downwards. Now the weight, because it's the mass, weight is the force under gravity, so the weight will be mg, m mass times gravity. So the weight acting vertically downwards, W is equal to mg. Okay, we've got the normal reaction of the block with the slope. And then we've got the tension in the string, or in the rope, sorry. Now, because it's on the point of moving up the slope, the friction will act in this direction. So the frictional force opposes any likely motion. Okay, so the frictional force here is, because it's on the point of moving up, will act in this direction down the slope. In the second case, where the block is at the point of moving downwards, then we've got the same diagram. It's got the same weight, mg. The weight is acting vertically downwards. We've got the same reaction between the block and the normal reaction between the block and the slope. So the normal is always at 90 degrees to the surface. And we have the tension that way. Now, because it's on the point of moving downwards, then the friction must oppose that movement. So the frictional force is opposing any likely motion, so therefore it's going in that direction. So this has been a video to draw a force diagram of a block being pulled by a rope, up a slope. I hope you've understood, and I thank you very much for watching.